Welcome back to the Deep Dive, where we take a stack of dense, specialized researcher source material and distill it into the crucial knowledge you need, quickly, thoroughly, and memorably. Today, we are tackling what is, I think, maybe the single greatest source of mistrust, risk, and just frustration in the world of advanced AI.
Hallucination.
Hallucination,
Right.
exactly. And we're moving past the consumer level complaints about chatbots getting trivia wrong.
Right.
We're diving into the really high stakes environment, R&D, material science, complex knowledge synthesis. If you've ever asked a sophisticated language model a question and gotten back a response that was fluent, confident, and just, utterly convincingly wrong, you know the exact problem we're digging into.
And that's a perfect description of it. The confidence is the dangerous part.
It really is. So our sources today are focused on this world of discovery intelligence, these DI systems. And these are systems built specifically to find new scientific truths or new technological solutions.
So in this domain, a hallucination isn't just, an embarrassment. It can lead to multi-million-dollar failures in research, or even dangerous miscalculations in things like material properties.
So the stakes couldn't be higher.
Exactly. And what's crucial here is that these experts, the ones who build these systems, they don't treat hallucination like a software bug you just patch. They see it as a fundamental system design challenge. It needs a kind of rigorous, almost scientific architecture to manage.
So what's our mission for this deep dive?
Yeah.
For you, the listener, we want to move beyond that common critique, which is often just, oh, AI makes mistakes.
Which is, not very helpful.
Not helpful at all. We want to understand the rigorous, almost military-grade strategies used to make these knowledge systems reliable. How do we get quick, thorough, and most importantly, trustworthy answers from systems that are literally designed to push the boundaries of what we know?
And to do that, to succeed in that mission, we have to start with precision. We need to immediately clarify what we mean by hallucination in this very specialized context.
Because the public term is just way too broad.
Yeah. Way too broad. In DI, the definition is extremely precise, and it's focused entirely on accountability. Here it is. Hallucination is the generation of outputs that are not sufficiently supported by evidence, constraints, or valid inference while still appearing fluent, confident, or plausible.
That emphasis on appearing fluent and confident feels so key, doesn't it?
It is.
It's the difference between a system saying, I couldn't find an answer, and saying, oh yeah, polymer X will self-assemble perfectly on Mars based on a paper I just invented.
Right. It's the difference between uncertainty and false confidence. But here's the essential clarification, and this really changes the entire framework for how we manage it. Hallucination does not mean lying.
Okay.
It doesn't even necessarily imply flawed data. A model can hallucinate even if all of its training data, every single fact it consumed, is perfectly correct.
Hold on, wait a minute. If every fact the system learned is sound, how can the output be factually unsupported? That seems like a contradiction.
It does, but it's because the problem isn't always the facts themselves. It's the structural integrity of the process that retrieves and connects those facts. It's fundamentally a system design problem, not just a data quality problem. The hallucination happens because of the way the system is architecturally allowed to retrieve information or synthesize it or extrapolate from it, especially based on vague inputs.
So it's an architectural failure, a failure to enforce scientific rigor in the process, not just a failure of memory.
Precisely. And recognizing that distinction, that it's about the system, moves us directly into the first core insight from the sources. The sources are really emphatic about this. The single most fundamental step in managing hallucination is recognizing that there are two fundamentally different categories.
Two different types.
Two completely different types. And you cannot manage them with the same tools. If you treat them the same, you will fail.
Okay, so what does that failure look like in practice? What happens if you mix them up?
It looks like paralysis. You either over-constrain the intelligent parts of the system.
The parts that need to be creative.
Right, the probabilistic parts that discover new things. You strangle them. Or you undermanage the simple solvable errors and you let these preventable flaws just corrupt the entire system's output.
So the goal is to separate the solvable engineering flaws from the necessary trade-offs of innovation.
That's it, exactly. Separating what we can fix from what we must simply manage.
So let's establish these two camps. What are they?
Okay. First up, we have Category A, controllable hallucinations.
Controllable.
These are on us. They're our responsibility as architects. They happen because of system design choices. Things like allowing ambiguity in a query or accepting bad assumptions, failing to validate your
It's
evidence.
sloppy
A
procedures.
sloppy procedure. And the good news is that these errors, they can be engineered away or strongly reduced. If your system is making these kinds of mistakes, the sources are clear. That's an architectural failure, a failure of rigor.
That sounds like the intellectual equivalent of not bolting down your equipment in a lab. They're procedural mistakes, and if you fix the procedure, you fix the mistake.
That is a perfect analogy. Then we have the other category, which is fundamentally different. Category B, unavoidable hallucinations.
Unavoidable.
These are inherent to the very nature of an intelligent system. They're baked into the probabilistic, statistical, and generalizing nature of how these systems learn.
So you can't eliminate them.
You can't. In fact, if you try to eliminate them completely, the sources say you would essentially destroy the system's intelligence, its ability to reason, to predict, to discover. It would just become a static lookup database.
Wow, okay. That is a crucial insight. We have to stop criticizing the system for being probabilistic.
Because that's where the creativity comes from.
Exactly. And instead, we start demanding absolute ruthless rigor where rigor is actually possible, which is in category A.
Yes.
That separation alone feels like it moves the entire AI reliability debate forward by years.
It fundamentally reframes the architectural challenge. So let's dedicate this next section to Category A, the DI playbook for engineering out those solvable errors.
Okay, let's get into this DI playbook. These controllable hallucinations happen because the system allows for sloppy work. So the focus here has to be on the architectural checks and balances, right? The strategies that force discipline on the model.
The system has to operate with the institutional discipline of, like, a major national laboratory. Anything less just introduces unacceptable risk. Hashtag tag 2.1. Input under specification hallucination.
All right, so let's start at the very beginning of the problem, the user's query. If you ask a vague question, the system is forced to assume context.
Right, and those assumptions are what our sources define as silent hallucinations. They are context invented by the model to fill a void you left.
Let's use that specific example from the source because it really clarifies the level of rigor we're talking about. The query, is polymer X biodegradable?
A perfectly normal question in a casual setting, you expect a yes or no. But scientifically, that question is. It's completely invalid. It's underspecified.
So why is it a silent hallucination if the system tries to answer that?
Because to even attempt an answer, the model has to invent the missing context. It has to assume, okay, they probably mean in a landfill environment, maybe at 30 degrees Celsius, using standard microbes over 5 years.
As of which the user never said.
Never said. The system just invented those 5 crucial assumptions to process the query. That invention is the hallucination. It's an invented context that's masquerading as a certainty.
So the mitigation for this is what's called the minimum condition set, or MCS. It basically forces the user to provide all the parameters for a scientifically valid experiment. Can you run us through those conditions again?
Absolutely. To truthfully answer, is polymer X biodegradable? The system must enforce inputs for 1, the environment. Is it soil, salt water, compost? 2, the organism or enzyme class. Which specific microbes are we talking about? 3, the physical conditions, temperature, pH, pressure. 4, the time scale. Is it a month, a year, a decade? Time is a chemical condition.
Right.
And 5, the measurement definition. What do you even mean by biodegradation? Is it mass loss? CO2 production?
Okay, and the sources call this a 100% controllable hallucination. So how does the architecture actually enforce that?
Through ruthless constraint. The system's architecture forces mandatory input fields for all of those things. And crucially, no auto-filled defaults are allowed.
So the system can't just assume standard lab temperature.
No, it can't. If any of those conditions are missing, the system must simply block inference. It has to refuse to answer.
Why is refusal the better choice? Why not just say, issue a warning and then give the most likely default answer?
Because a guess, even a guess with a warning, introduces liability and unsupported claims into the system. That guessed context, that silent hallucination, could send a scientist down a year-long path of fruitless research. Refusal forces the user to be accountable for the conditions. It mirrors real science, where your experimental setup is everything. The system is designed not to be a pleaser, but a gatekeeper. Hashtag tag 2.2, evidence mismatch, hallucination. All right, so once we have that precise input, the MCS.
The rigorous setup.
Yes, the system then has to make sure it's retrieving data that actually adheres to those constraints. And that brings us to the next major failure point, the evidence mismatch hallucination.
This happens when the system reasons over data that doesn't strictly match the input conditions.
This sounds like what we were calling cross-context leakage.
Yeah.
How common is that when you're dealing with these huge scientific databases?